All right. Well, hello. Good morning, good evening, or good afternoon, wherever this video finds you. We're going to go ahead and talk about our chapter 8 about strings. And one of the main, the importance of understanding and manipulating strings is pretty high because a lot of what you're going to be doing is processing strings. In fact, that's how an interpreter is created, even a compiler. As a data scientist, they manipulate strings all the time for data. Also, cybersecurity uses it for SIEMs. One of the main things that we call that a SIEM. Let's go ahead and just kind of cybersecurity SIEM. So a SIEM is basically a program that waits for a log file from a service, such as, and this is kind of, I'll leave it to you guys, but to research more on what an SIEM is or a SIEM. But what the main goal is that is a program that sits on a server waiting for log files from a service. And a service could be like an Apache service, which is a web server that could be sending you the log files of every IP address that accesses a certain page on the website. So a lot of times within that program that is getting those log files from your services on your network, you will have the ability to do some scripting that will allow you to get those logs and that text of those log entries and manipulate them to show a picture of what's going on your network. And it's really important that you're able to do this for rapid, response to an intrusion, so that you can visualize what's going on. Because, I don't know about you, but a million lines of text about every IP address that accesses a certain web page, at what time it accesses it, or if you're a data scientist, thousands and thousands of web pages with the strings inside of it that represent the HTML of that web page. That's a lot of information to process. So when we're working with strings, we do what's called parsing and tokenizing of the string. And, I've talked about that a little bit before, but parsing and tokenizing of strings is how we identify certain things within that text to either visualize or inspect. And also, primarily, it's one of the main jobs you do as a programmer is slinging around strings. I call it slinging strings. You're getting strings from information sources and manipulating them to identify or get an answer, or identify something or get an answer. So string manipulation is rather important. Now, fortunately, the higher level languages, and I'm not talking about C or C++. C or C++, it's a pain in the butt to deal with strings. But the higher level languages like Java, C#, even JavaScript, Python, they all have special functions like the split function that we've also talked about, that we'll look into a little bit more, that help us with parsing and tokenizing those strings. So without further ado, now that we've kind of got the why, let's get into more about strings. And so we're going to talk about some of those basic string operations. One of the things that is used is a term that's used is string slicing. I use the term tokenizing. So slicing and tokenizing, tokens and slices, those are interchangeable. Searching is part of tokenizing and slicing. Manipulating strings is also a part of slicing and tokenizing. So, there's a lot of different operations that you may need to do on strings. And of course, there's lots of tools that you have available to you, such as data visualization. You could read log files and show the metrics or graphical charts of, say, an IP address that's accessing this web page a little bit more often than it should be, or have ways of detecting irregularities that as part of your examination, or data that you need to find in a web page as a data scientist, and then of course visualize that data if needed. So when we refer to strings, we use that one word strings, but an older term is a character array, because a string is a sequence of characters. So it's actually an array of your ASCII code characters. And that's what a string is. It's just a sequence of your ASCII code characters that we've talked about before a few times. This guy right here. So it's a bunch of these guys all together, and that's what we refer to as a string, is that sequence of characters. Now a string can contain new line characters, carriage return characters, tab characters. So when we are manipulating strings, a lot of times we have to take data that's in its text format and convert it to its numerical format so that we can process those numbers. And of course, we've already talked about that and delved into some of that. So that's what we're working with. And as we go through these PowerPoints, we're going to also take a few pauses to kind of visualize what's going on and in a demo. I'm going to demo some of this stuff, but one way of accessing individual characters in a string or a sequence or an array is by using the for each method. And I use that term for each. That's the way it's implemented in other languages. But in Python, it looks like this: for something in a string, some variable for a character in the string, and then you can access that character. Now you can also use an indexer and use a for loop with the range keywords to loop through a string. So what is it that we're actually looping through? Well, we're looping through a specific character in the string. So let's look at the two different ways. I'm going to show you two different ways of looping through a string. And remember, this goes back to have get your memory, print your memory. I mean, you can't do anything with it unless you're able to visualize it. So let's begin in that mode. I've already got kind of some preparation here for you. What we're going to do is we're going to just define a string here. And I'm going to go ahead and say x_str. So that's going to be a string. And I'm going to say the quick brown border collie jumps over the cow. Now, okay, so that's a string that we're going to loop through and manipulate, and we want to just examine each character in this string and make some decisions based on what characters we find in the string. And for that, we have to actually loop through the string, and we can use the for statement. So I can say for the char, the character that I'm calling C, the char C, and I'm just going to shorten this to just C. For C, and you know, C is, that's rudimentary. Let's just do C underscore char. That way that we know it's a character. I always like to, you know, identify in some ways, you know, what is the data type that we're working with. So for the character called C in X underscore str. So for every character in X underscore CR, let's just do a simple print C underscore char. And that is how we loop through each one. Now let's go ahead and set a breakpoint so we can visualize kind of what's going on. And I'm going to go ahead and do a start debug. Okay, so the first time through the loop, what it does is this for statement essentially starts with the beginning character to point C underscore str is the CH is going to point to the J here first. And then every time through the loop, it's going to advance through each character as we examine it. Now we see here that I've got this print statement inside the scope of my for statement. So beginning out, oh, it looks like I am got some issues here already. Interesting. Well, you know what? This is, you know, hey, it's a little bit early in the morning because it looks like, you know, this is very typical. We would get an error, but it has nothing to do with actually what's wrong. Very typical in programming. It says X underscore str is not defined, but clearly I look up here and it's defined. So something else must be wrong. And then I look at it and yeah, sure enough, I didn't indent the for loop. Very typical, guys. And especially, you know, it is a little bit early this morning. So let's go ahead and restart that. Okay, so I just advanced and did a step over that first line. And what happened is char was assigned the first character in the string, which is T. And then we print T down below. Then I advance to the next one, which is an H, and I print the H down below. So we can kind of see we got TH down here. We can see over here in my locals, I see my whole string as a full, and then every time through the loop, that H is being advanced through. And so I'm doing, you know, this step over, and I'm just advancing through the whole, every character that's in that string, and it's going to continue on until it's done. And what I'm going to do here is I'm just going to hit this. So it says the quick border, the quick brown border, call it whatever. Okay, I'm going to go ahead and hit continue here, and it goes to the next one. So I'm going to remove this breakpoint and then hit continue, and it's going to finish up printing each character that we advance through. So that's the first example of parsing through a string. Now we have another way of parsing through the string that is more traditional than the higher level language's use of a for each statement for every character in a string. And that is the using the index of the character in the string. And for that, we need to use the len or the length statement, and we need to use the exclusive portion of the for in range. And then, so what we're going to do is we know that it defaults to starting at 0. So I'm going to say for go until the end of the length of C underscore char. So let's look at kind of what happens here. I think I got that correct. Oh, no, I don't. Look at what I just did. I did a stupid. I need the length of the string, not the length of the character, silly. Okay, so 4x underscore str. There we go. Now I should have something that looks like it'll work. Let's go ahead and set a breakpoint here. And I could have messed up again, but yeah, I did mess up something. You know, 4 in range. Well, this is interesting. Well, fortunately, I'm ready for a minor coffee break, and I'm going to figure that out. It could be something simple as a syntax statement. I'm going to go ahead and reference it off camera, and then when we come back, I'll let you know kind of what I'm doing wrong. I'll be right back, guys. All right, we're back. So I clearly got ahead of myself here. I also zoomed in a little bit more for you. I forgot that we're actually doing indexing instead of the for each statement. So I neglected to put in my I in here. Now, you might ask, why do I use I? Well, guess why? It's just tradition when we use counters and indexing within programming that we always use I, J, and K for counters. Tradition. So I kind of guesstimate it's because it's an integer, I. But one thing that we're doing is we're using I to go to less than the length of the string. And then we need to print the string's index at the I position. And that will give us, kind of, what we need for this example of parsing a string. I would not, one thing is, here's kind of a general rule that I always make for myself when I am working with loops and arrays or lists or sequences. I don't use while loops or do whiles. I always use for loops because they have a better control over the indexing. It's really easy to get an off by one error with a while loop within your algorithm. So I would hesitate to ever work with parsing a string with a while loop unless it was purposeful and it was needed. So try to always use for loops. And I'm only making that statement because it's a favorite thing that I always say. Who's the one person that's working against you when you're programming? There's only one person working against you, and it's yourself. So know yourself when you go in and do a job, and that's one of my main things with that is knowing myself. Work with some constraints. Let's walk through this and see what's going on. Let's look at what length of x underscore str is doing. So I'm going to go ahead and just copy that whole statement. And I'm going to go over here to the watch. And I'm going to paste that in. And I just want to see what is returning when I put the length of the string in here. And so the for I in range is getting to 49. So this loop is going to go from 0 to 48 for the indexing. So it's going to start at 0 for the T, and 48 will be the period over here. And so when we say x underscore str of I, we look at I is 0. So what is x underscore str of I when I is 0? And we can throw that in the debugger and see that it's T. And then, of course, we can step through each time, and we see that if you look over here, that this is advancing through every time, and it's showing us our output. So do try to use the debugger, guys. Seriously, I'm going to harp on this all quarter long. You will have a social life when you work with the debugger, because it is the best cheat sheet in the world. You literally are given the answers. You just have to put it in here and work it out. So this is going to advance all the way through and parse that whole string. So I'm going to go ahead and remove this and hit continue and allow it to finish its processing. And we see that it's printed out the whole string. Okay, so those are two methods to parse a string. Now I can show you where we can do this with a while, and we'll say that while I is less than the length of x_str, and then we can just get rid of this guy, but then we are needing to first create I up here. I is equal to 0, started at 0, and then every time we need to do an I plus equals 1. And this is going to do the same thing, so you can use a while loop to parse through a string, but again, this is not the way I would recommend doing it, because it causes problems within your algorithm unless it's purposeful. So try to use a controlled for loop as much as possible when you're parsing a string. Okay, that takes us through parsing strings and accessing individual characters in a string. Okay, so we can get what's called an index error whenever we go outside the length of a string, or we try to access a portion of the list or array that does not exist. And what will happen is you get an index error thrown. Now this is good practice. This is one I'm not going to particularly expect you guys to actually have in your coding. What I really want is you using try and catches from whenever you get user input. And when I do an example, I will demo that. Eventually I will be having you return or resubmit your assignments if you don't do a try catch when you get user input and convert it to, if you're getting user input of a number that needs to be converted from an ASCII code character, that should be done in a try catch. Input validation is a tenet of cybersecurity and good programming techniques. So this is good practice. We would do a try. And you know what? For this one, because I'm a little bit unsure on the syntax and semantics here, this is a good example of using a resource to find what we actually need. We need to catch an index error. So I'm just going to say, hey, well, how do I catch an index error? And I'm going to go here, I'm going to type in Python try index error and see if we can't get an example of a try catch with an index error out of range. And here is an example right here. Okay, so evidently I'm not doing very good at scrolling today. Something's going on with this machine. I'm gonna, for some reason it's thinking pretty hard. Here we go. Here it is. Let me zoom in. You know what? I'm just gonna copy it and paste it in, and then you guys can see it in the zoom of the Visual Studio Code. Okay, so this is the code that I found that we're going to use an example. We have, and let's get some nice pretty indexing in here. We have a try and an accept. We have a list that we're processing, and we try to access element 3 in this list when there are only 3 elements in the list. Now remember, 3 actually means 4, because this is the 0 element, this is the 1 element, and this is the 2 element. So element 3 does not actually exist. It's not there. So to properly do this, what I would do is I would put a try here around this parsing mechanism, and this would be for creating some bulletproof code. You know, and always think that your user needs that extra help. And I'm saying this from my own personal, you know, we make mistakes. We get it. We start out the morning and we don't have enough coffee and we forget things. So these sorts of things are very important with good design and implementation. So you see that we got some obvious errors here. Well, that's because the while is not inside the scope of the try statement. So what I'm going to do is I'm going to put this while inside the scope, and then I have to put this print inside that scope of the while statement, and this guy inside the scope of the while statement. But this except is okay. Now this is going to run and work just fine, but let's say that I am being silly. And let's throw in here, instead of while less than the length of the string, I'm going to throw in 100. And that means that obviously we don't have 100 characters in this string. So that means that at some point, I'm going to get an error. And that error is going to say, hey, index out of range. But here's the nice point. Is I can write all kinds of code here. I can have all kinds of code that will work because I've caught the error. And remember, what a catch does is it actually changes the flow of your program. So you can think of that the code inside of Python that looks at an index of a particular string, you can say that it throws the error. So the error would be like a baseball. And it throws the air. The baseball is the flow of your program, and it throws the flow of your program out so that it skips over this line and it goes right to catching the error before any other processing happens that may totally wipe out and blink out the program so that it's not running whatsoever. And this would be very important, especially if this program were, say, an autopilot application for flying a plane. Yeah, I think that would be fairly important that we would catch an error like that. So that good practice really, you know, when you get out in the industry, you know, start making those habits as soon as possible. I won't always demonstrate those good habits to you, but also when you get out in the industry and you work with a mentor, they will harp on you about those good habits. I know from experience. I was an intern at one time myself. Some interesting times, but let's not get too far into that. All right, let's throw this error and let's see what actually happens. Let's see. I'm not going to go through here 100 different times. Let's make it so that we only have a string of 2. Let's throw the error first and then we'll examine it in more detail. Okay, so the error got thrown out of range. So let's examine this in more detail so that I'm not going through 100 and so characters. Let's just make it down to 2 characters. 2 characters in the string. So let's set our breakpoint for our while statement. And I have my while I is less than 100. Well, this is good because the string at location of 0 where I is 0 is the value t, so there's no problems here. And it goes down to where, what is the value at location 0? Well, at location 0, it's h. Oh, all right, excuse me. At location 1, the value in the string is h. Now we iterate I plus equals 1. Now I is 3. So now we have a problem. And in our watch, we even see that this is a problem. An error is going to happen here. An index error is thrown. And the watch even shows it. That's kind of cool. But it's not until we actually process it that throw will happen in our code. Here in the code behind the scenes, obviously an error was thrown and it's showing it to us in our watch window. But we haven't tested it in our code. So let's look at what happens here. This is where an error will be thrown, and it's going to throw the flow. It's going to take our flow, and our flow is going to go over this line. So this line number 8, will not be processed whatsoever. The error actually goes and throws the flow of a program like a baseball, and this exception is the person catching that ball or the flow of your program. So, boom, we move right there. The ball is catched. We found an index error. We flow over our program and we output. It's out of range. And we can have more code down here that will work, that will continue flying that plane. And we won't have an epic disaster that will go on the news or whatever. But yeah, okay. So that's working and parsing strings. Let's go ahead and get back to a little bit more on the PowerPoint and continue on. So string concatenation. So this is, essentially you're going to be doing this a lot when you're working with a string, because when we, every language, the way it works is that the string object, and you can think of the string as an object because it actually has functions inside of it that can operate on the string. The string object, when it's built for every programming language, it's not allowed to be changed. You can't directly modify the data inside of a string. You have to take the data inside of a string, and if you want to modify it, you modify it in a new string from the old data. And so a string itself is, and the data inside of it is unmutable, immutable or whatever. It can't, it's safe. And that's a tenet of object orientation and object programming. And the string is an object, so we don't allow the data inside the string to be changed. So if we want to take the data and modify it in some way inside the string, we have to take it and assign it to a new string. And that's one of the main things that I always had a problem understanding when I first started working with strings, is the fact that they wouldn't let me change the data in a string. I always had to modify the data to a new string, which means that you have to use the equals operator. For that, we are going to get into here. Strings are immutable, but what I want to do is I want to talk a little bit about concatenation. We've kind of already talked about that, but concatenation, let's get in with an example of that. And what I want to do is I'm going to take a short break and come back and we will delve into that. Okay, see you guys soon. Right, let's continue on talking about string concatenation. And with the plus operator, you can also combine numerical values with this. Sometimes you may have to do a conversion for it. Well, let's go in and find out. You can also use the plus equals operator for that. So string concatenation is where you're just adding two strings together. And a real simple example of that would be, when you're doing string concatenation, because since you're actually forming a new string and strings are immutable, you're going to be adding the concatenation of two strings together to form a new string. So the new string will be the one string added to another string. And then of course, you can print that out in its entirety. All right, let's just kind of look at it. Here's our printout, the border. So in other words, this string was added to this string, and the resulting string was both strings put together. In the debugger, we can even look into it a little bit further. Oh, yeah, okay, there we go. So we've got X string, the Y string border. We declare a new string called C string, which is going to be X string added to Y string. And then now C string contains both those words together. Now you can also add numerical values to this. And let's say that I is 99. So let's add I to that and see what happens. Sometimes this, so you see we got an error here, and the reason why is because I is actual numerical value, so we would have to convert it to a string, and then the addition operator can work. And now we have C string, which is the border 99. Often when you're adding two strings together, you may want to put spaces in between them. So we can inject a space between these guys by surrounding it with pluses. And this is a very common thing that you find that you need to do. So now we have the border, the space, border, space 99. And then in loops, you may want to have a running addition where you would use sometimes you would use the plus equals, where we're always adding a to the end or something, who knows. It could be in a loop where you're building a sentence from tokenized words that you would use the plus equals. The plus equals essentially is the same thing as C string plus equals A is the same thing as C string plus C string is equal to C string plus A. It's just, it's a lazy form, a shorthand, essentially. Okay, that kind of gets us into pluses. Now here's an example of immutable, not being able to change a specific piece of data in the string. So we actually have to run special functions on the string that allow us to change what's in the string, or we assign a new string to a current string that we want to modify in some way. So essentially, we can't just go in. We can say, hey, outprint C string of location 3, or location 2, which is the E. But we cannot just go in and change that position 2 equal to, instead of let's say we wanted to put a B up here, we would say C string at location 2, the particular character E, that location, I want it to be a B. And since we're using, I think the Python, it doesn't really matter, but that's common languages when we're referring to characters singularly, we use the single quotes. That's pretty much most languages out there. Python is so type safe that you can use them interchangeably. Okay, so this you can't actually do. This is illegal, and we would actually have a problem with that with this actually working. So if I set a breakpoint here and I try to do a step over, we're going to have an exception error. We can't assign to data inside of the string. And what that means is this is an object, and with object-oriented programming, the whole point of an object is to protect the data. And with a string object, the data that it protects is the characters in that string. So what we have to do is if we want to modify a string, we need to use functions inside of the string for that modification to happen. So some of those functions we're going to be talking about shortly. As we get into it up here. So let's go ahead and skip a little bit ahead to this one right here. I believe it should be a replace function. There we go, replace. So if I want to modify a specific value in a string and change it to another value, I can use two different functions. I can do a find and either use an index-based replace, or I'm thinking that with Python, no, Python, it just works. You send it the string, the replace with the string. So we would have a string that we want it to replace inside of the current string. And so these functions, you actually act upon the object. That's the whole idea of object-oriented programming, is not only is it data, but it's data that you can act on with functions that are applied to the object itself. So in that case, what we'll be doing here is, let's say that we want to replace this E with another character. So what I would do is I would say, hey, string, and notice I'm using the dot here. So what I'm wanting to do is I want to run a function on the string. Now these are all the functions that you have available to you, such as, is it a lowercase, the strip functions, find, union, fill, all these things. These guys are, some of these are properties, some of these are functions. A property would be a piece or some data, an actual variable that's in its primitive form, such as like a normal integer, a floating point number, or characters. A function would be something that actually carries out an actual job. So let's go ahead and run this replace function. And what we're going to do is we're going to send it the character. I believe when we looked at the PowerPoint, you send it, the first argument is the old, which is going to be an E. And then we give it the new, which we want it to be a B. And then what we'll do is we'll do a print C_str. Okay, so we are working with C string here. We are replacing the E with a B, and it looks like I may have told you incorrectly. Yeah, okay, that's right. That would make sense, because it would want to maintain the integrity of the data inside of the object. So there are some functions that would allow you to change the data inside of it, but the replace function is definitely not. So we would actually have to assign this to a new value, a new string value to actually get the change. There we go. And you know, if you ever want to know whether a function is, you know, allows for a mutation, we call it a mutable function, or a function, a mutation, or a function that allows a mutation. That means it's a function that allows the data inside the object to be changed. In the case of replace, let's just kind of double check and make sure that what I'm telling you is not incorrect. So what we're looking at here is a string, and let's do a print of a string here. We're looking for it to make a change. Okay, so C string is not going to be changed. Oh, yeah, there we go, a string. So a string, you notice here that it has now the B inside of it instead of the E. Okay. I think we wanted to do something here, then convert it to a string, this character, but that's okay. Let's move on. I think we want to actually do a different type of conversion. I don't want to get into the weeds though. I think we've got that. We know that replace is an immutable function that returns the new string once it replaces it. And you know, I'm not for sure if there are any immutable functions. Mostly, you know, when I build an object, I don't allow anybody to change the data unless it's through a special set function. And when you guys are building your own objects later on in the quarter, you'll kind of have a better understanding of mutable, immutable, and you know, properties of an object and so forth. So don't get, you know, that's going to be coming to you soon. All right. So to change a string, we have to assign it to a new string. And now we get into a slice, and let's say that we want to grab a part of a string into a new string, and that's where we send it an expression where we use an index. We use an index expression to, and this is another way to tokenize information inside of your strings. But you're going to be sending it integral values that represent where you start the slice and where you end the slice. If you omit the end argument after the double colon in here, it's going to interpret that you mean for the length of the string, for however many characters in the string. And if you omit the start, let's say you just leave nothing there, you do a colon, and then you put a number here in the end, then it's going to interpret that you mean at the beginning. So if we're going to play around with this, let's say that we want to grab information out of a string, but we want to do a C string dot slice, and the step will actually tell it how much or how many characters to slice from. But I don't think we're going to be using the slice in this way. We're going to be using it the shorthand, the way your book is describing it. So your slice can work in a couple different fashions. Let's say that we give it nothing here, and we say to go to the 5th item. Will that even compile or interpret? No, we actually have to put the value in. Now that is interesting. Why is it saying 0 is used if a start is not specified? Oh, okay, yeah. That is only not when you're using this way of doing things with the colon. Only when you are using the start and step example. or way of slicing a string. Let's just play around with it. So you actually have to send it both. So let's say let's go from position 2 to 5. Now this is really interesting. Maybe I am going a little crazy. You know what, guys? It's time for me to take a break and solve this little issue and see what's going on, and to come back and talk to you about what I'm doing wrong. I'll see you guys in a little bit. All right, yeah, so I was being silly. It does omit. I was using the wrong syntax. So I was using the parentheses, and we need to use the square brackets for the slice. Let's say that we want to slice from 2 to 5. So that means that C string from position 2, and if I remember right, C string has, let's get in the debugger and just look at it. C string from 2 to 5, so 0, 1, 2. So it should start with the E because the first argument should be inclusive. And then let's see if the second argument is exclusive. I'm pretty sure it is. 2 to 5. So this is 0, 1, 2, 3, 4, 5. So we should be going from E to O. Let's see. Oh, golly. I'm going to have to really play with this. Oh, yeah. Okay. Now, a few things make sense. I was using the slice function instead of the slice, the shorthand slice. So you do have a slice function that you can use, but let's keep to the PowerPoints, and let's use the slice in shorthand. And this is where mostly I see a lot of data scientists do a lot of tokenizing using slice in this manner instead of the slice function. You essentially take the string itself, and instead of running the slice function on it, which behaves a little bit differently, if you see it's got a start, an end, and a step, we are going to actually use the index slice method, which you would use the square brackets. And we're going to go from 2 to 5 in this one. And let's see how this behaves in the debugger. So what I'm assuming is that we are going to start at the E and go all the way to the 5th location. So this is 0, 1, 2, 3, 4, 5, oh. Now what would be interesting to see is if that 5 is inclusive or exclusive. Let's find out how it behaves. Okay, so it's exclusive. Yeah, it's exclusive. So the 2 is inclusive, and it goes right to just before the 5th one in the string, which makes sense because when you're doing slicing within a loop, you always have that off by 1 issue that you got to solve. And that's why you have that inclusive exclusive behavior and a lot of the functions that you work with, and yeah, it gets confusing, but it's all because we start strings at the index level of 0, and really in real life 0 is 1 in a lot of ways. Okay, now let's try that omitting one. Oh yeah, now it wants to work for me. That's nice. Now that I'm using it correctly. All right. There we go. So it should start at the beginning and go to the B. Okay, and then so we got it starting at the beginning and going to the B. Okay, so that's an example of working with the array-based or list-based slicing mechanism that uses your bracket, your square bracket uh, syntax and semantics. Now let's look at this in function. That is just to find, and all in does is take two arguments. Two operands is what we call them. Operand 1 will be string 1, and operand 2 will be string 2. And it checks to see if string 1 is inside of string 2. And all it does is return a true or false. That's all it cares about, is a true or false. So you can write it on one line of code, but it's better to, I mean, obviously we would want it to be inside of an if statement, because usually we would use an if statement to look at a true or false. But what we can do is we can do this. We can say, hey, print whether BOR is in C string. Now, what I'm doing is you notice how I'm using a lowercase here, and I just want to see whether it behaves, whether it's type safe or not. I'm pretty sure that it's not. That's not the way I would build it, but hey, you know, Python is meant to be easy and not be difficult. So let's see what happens here. And what we're going to do is we're going to just select this as a whole. I'm going to select this whole line inside that the print is looking at. I'm going to copy it and I'm going to throw it over here in the watch. Okay, it turns to false. Good. Good for Python. Thank you. That's what I would, that's the way I would build it. Let's go ahead and do the capital B. Now let's try it. Let's get rid of this guy. Let's add that syntax again, but let's put the capital B inside of there now. And it returns a true now. So it is type safe. Or it is type specific, excuse me. Or syntax, or uppercase, lowercase, specific. All right. That is a good example of using the in, but primarily what you would be actually using this for is for this kind of statement. You would put it in the if statement and use it that way. And that's just to find a string inside of another string. All right, now we get into a little bit more on some of the string methods that you actually use to act upon the string. And some of those are the is alpha, and these are, alpha, it does matter whether you are comparing uppercase or lowercase. When you are working with comparisons of strings, however, when we are just looking at is alpha numeric or is alpha or is digit, is lower is the only thing that really matters, and is upper when it comes to being uppercase or lowercase. Because of the is alpha will always return a true, whether it's uppercase A, lowercase b, lowercase a, etc. So it's always just going to look to see, hey, is it an alpha character? And what it does is it converts, when you look at your ASCII code, it'll convert the character that it's looking at, and I'm talking about the is alpha function now. The is alpha function will convert the character that it's looking at and just see if it's if it's got the integral value 65 to 90, or the integral value is 97 to 122. And what that's doing is saying, hey, yes, this is an alpha character. And you will find that you will need to check that very often when you are working with parsing and tokenizing text files. IsDigit does the same thing, but what it's looking for is to see if the character value is between is the value 48 or between 48 and 57. And that's all it does, is it converts it to its integral value and puts it into an if statement. And you know, you can build those functions yourself, but why? They're built for you. And let's just kind of do an example of that. If let's do this. If this is alpha. Now you see what I'm doing there? That's kind of a little bit tricky for me because I'm just taking the string literal and treating it like it's the string object. So I can create a string, a t-string, and assign it to BOR, and then run the alphanumeric. I'm going to do isAlpha for this one. On the string itself that I've created as a variable, or I can just directly apply and say take that literal value and apply the string function to it. So you can use these string functions in different ways by, you know, using the literal representation of the string and saying take that literal and apply the string function that's built inside a string to it. Or you can, you know, use the actual variable name that you assign. So let's just look at this guy and play with it. And all those is functions, those all return a true or false. So let's do this. Bor. And let's look at that. And we'll say bor is alpha. Step over. Boom. Did we get a printout? Yep. Bor is alpha. Now if I change that to if is numeric, that's going to return a false. If I change this to t_string, I'm just doing the same thing, except for I'm using the variable name to run that function on. That's going to return a false because its BOR is not numeric. Now, the alphanumeric, what it does is it looks at the characters and it only returns a true if it's a numeric value, if it has numbers in it, or alpha, as soon as it finds any kind of weird character or your special characters or whatever, it's going to return false because it's not an alpha or numeric value. And so these will be common functions you use. Okay, so this gets into you know, the discussion about you know, some functions like we saw with the replace function earlier, that it only returns you know, it only allows you to change with returning the new string. And then we've got string, essentially string comparisons that are case sensitive. Now that's the word I've been looking for the last 10 minutes. Why did I forget case sensitive? Okay, thank you. Lower and upper, the lower and upper methods can be used, and you want to use them to return a new string that represents the lower representation. So let's look at that. Let's say that I want to take and do a Z string and assign it to T strings lower. So this function, this is a function that acts upon the strings that is it's not a mutable function. It just returns a true or false. This is a function that will actually change the data of one string, but it assigns it to a new string. So let's look at what Z string is after it converts that B to our lowercase. So we go over here, we look at Z string in our watches folder. Why is it? Oh, there we go. Okay, there's Z string, lowercase b-o-r. Okay, substrings. We can find a substring. We can use ends with to search for a substring, starts with to begin at the beginning, to check to see if a string starts with a particular string. These are all kind of just modified versions of the find function. So let's look at actually an example of how to use the ends with. And let's see this. Let's see if T string dot ends with, and let's throw in OR. Oh, why are you doing this to me? You silly thing. Okay, now let's see if that ends with OR. And we know T string ends with OR. But this one, the ends with and the starts with, they only return true or false. What if you want to find the location of a place in the string, in a current existing string, and you want to find a substring inside of it? Let's say that we wanted to find OR inside of the concatenated C string, which is the border 99. So this will return a true, and let's just go ahead, copy that, throw it over in our debugger, and we can verify that we got a true. There's our true. Okay, now let's play with our find function. I think we already played with the replace, so we don't really need to deal with that. We already played with the ends with, the starts with, the find function. Now the find function will return a -1 because the find function, it returns a number. That's it. Just all it's concerned of is finding the beginning index where the string that the substring of what you're trying to find is inside of the master string. And that way you can parse through a string without actually having to go through it character by character, because that's what the find does for you. And usually in other languages, you actually have to build this yourself. Other languages, I mean C and C++, which is just a nightmare. But it's built for you in Python. And it'll return the starting index of where that string is located. And you already know the size of it because you're looking for a specific string inside of the master string. So you only really need to know is, hey, I found this word in this big old bunch of text. And then you just need to know, hey, where did you find this word in that text? Because a string can represent a whole book, or just a page under the book, or just a sentence on the page, or just a single character, or just a word. And let's say that we have a large string that represents all the pages in a book, and we want to find just specific words in that. And you guys do that all the time with your find tools for, you know, website, web page, looking for a web page, your Control F, and so forth. So let's look at find, and let's see, let's just do this. Let's just print the return value of find, and let's say we want to find OR inside of tstring. But since the find function is something that's going to operate on the string that we're looking at, we're going to use t_str dot find. Oh, not case fold find. There we go. I think I'm using, oh, just indent problems. Okay, there we go. So this will output where it finds the OR inside of there. And I'm just going to look at the output. It starts at location 1 and the OR. Now that's interesting. Oh, because I used tstring instead of cstring here. So tstring OR begins at location 1. Okay, that works. All right, where are we at then with... I'm going to skip over the repetition operator. You know, it's kind of funny, you know, but it just repeats. You guys go ahead and play with that. Actually, you know what? We will play with that because we've already covered the split method. So I'm not going to go into the split method. Let's play with the repetition operator. And if you want to know more on the split method, refer to one of my previous videos. So let's do this. Let's say that I want to apply a specific amount of times the string to copy times n. Okay, and I want that to happen multiple times. So right here I'm saying tstring is equal to BOR. Let's do this times 1,000. No, let's do 10,000. I'm just having fun. It's gonna go for a while. At least I thought it was. Oh, I didn't. Duh, it's not going to go unless you actually print it. So then, essentially, it's going to copy BOR 10,000 times into tstring. Then we're going to print BOR multiplied 10,000 times in that one string. And then there is our 10,000 BORs. Let's just get cute. I don't think it'll be able to handle it. Yeah, it decided I'm done with you after a little while. It only print out the last little bit of it, not the full 1 million. You probably have to throw that into a loop. Okay, guys, that's your first video. We're gonna get in and do some demonstration and have some fun with your next video. Take care. Bye-bye.